Okay, so in our previous session, we started our conversation about hypothesis testing. Anyone, any questions on hypothesis? This has to be a super interactive class. We are getting into the core Six Sigma portions, so please participate. Otherwise, it will become very complicated for you. Anyone, any questions on the concepts of hypothesis that we've discussed? Yes, no?
No, sir.
So in the previous class, we started by saying that the choice of the hypothesis test is dependent on data type of your Y and X. We started to say that broadly there will only be two subgroups that we will have to look at. Either your project Y will be continuous data, and for a Y which is continuous, only two possibilities. Either your X is also continuous or your X is discrete data. With me, everyone? Let's say I am doing a project on handling time, cycle time, something like that. So either the data that you've gathered for your factors is either going to be continuous or discrete. There's no third possibility. Similarly, when you have your project Y as discrete data, you will have the same situation. Either your X could be continuous or your X could be discrete data. Y discrete, I am doing a project on count of defects, count of production, while my factor is continuous, age of the machine breakdown time, or my factor could be discrete, like shift, supervisor, and things like that. So only two subgroups are possible, and they are not overlapping at all. So you will have this initial question for yourself, whether your data is continuous or discrete, and then that will resolve most of your problems. And then we will start delving into these portions. So situation one, Y is continuous. For example, I'm doing a project on cycle time. Or I'm doing a project on handling time. I'm doing a project on stat of hiring or stat of complaint resolution. So for your Y continuous, we are saying that there are only two possibilities. Either your factor will be continuous or your factor will be discrete. So if you are in a situation that your Y is continuous, like cycle time, and your factor also is continuous, in that case, from a hypothesis testing standpoint, you have two tests that are possible. We are saying Y continuous, X continuous. Either you can use a test called regression analysis, or you can use a test called correlation. And the graph that you can make, the data visualization tool that you can use, is referred to as scatter plot. I'm saying Y continuous, X continuous. Test number one that we have, the option number one that we have, is referred to as regression analysis. My project Y is C9 total breakage. My factor is production in kilogram. I go to stats. I go to regression. I go to regression. I use the fit regression model option. Total breakage versus production in kilogram. Press OK. You have a lot of information here. I will take a screenshot first so that we can discuss this. The first thing that you look at when you are using the regression analysis or most hypothesis test will be to look at the p-value. So step number one, when you are conducting your regression, how are you reading it? Step one, check p-value. Null hypothesis in a regression analysis will say X does not impact Y. Alternate will say X impacts Y significantly. In our case, we see that our p-value is 0, meaning, as in our example, p-value is 0, yeah, which is less than 0.05. We conclude that factor impacts the project Y significantly. Everyone clear with this so far?
Yes, sir.
Yes. Yes.
Then step number two, if P is alternate, check for R square value. R square referred to as value of significance explains the percentage impact of X on Y. It tells you how much is the impact of your factor on your project Y. The industry standard is 62%. Which means that if R square is greater than equal to 62%, we consider that the magnitude of impact is high. Let us look at our case. Our case, what is your R square, people?
8.3.
8.34.
While you wanted a 62% and above, how much did you get? 8%. So it is almost negligible. Only 8% impact. In our example, R square is 8 point some percentage. We shall not consider the magnitude as high enough. People, we're good so far?
Yes, sir.
Yes, sir.
Sir,
Hmm.
sir, what is the difference between R square adjacent, and R square product, and something is there?
Sure.
There are three R square value.
Sure. Step 3, if P is alternate, R square is
Sir,
greater.
sorry, another doubt. The industry standard, the 62%, does it have a background calculation, or is it just that based on all the industries which
We will
follow
derive
the
it.
same?
We will discuss about it.
Okay.
So ideally, we are saying that on the relationship can be positive or negative when you are looking at any relationship. So here we are saying if the relationship, so think of a scale of 0 to 1. We are saying if you are around the threshold of 2/3, only then will I consider you as significant. 2/3 could be about a 66 or 67%. No?
Yes.
That is right. That is right.
Okay.
If P is alternate, R square is greater than 62. Use the regression equation also. If you see here, we got a regression equation saying total breakage is equal to 6.05 plus this many times of production. If the P value, R square and P value were high enough, I would have been able to use this mathematics to be able to conclude. So if I give you a production target of 1,000, I would know how much breakage will I get. Everyone with me?
Yes, sir.
Yes, sir.
Or if I want to have a defined breakage that I don't want to break more than 10 kilograms today, it will help me decide how much production should I do. Correct, na? Everyone? Yes, no, black, white? Engineers?
Yes, sir. Yes, sir.
No doubt in this?
Sir.
You will be able to do this? Yes?
Yes, sir.
This is very, very crucial in advanced studies. This will make a lot of difference to how we run our business. So when you are looking at R square, when you are looking at doing your regression, you should look at p-value. You should look at R-square value. You should look at regression equation and decide whether the factor actually impacts, and if it impacts, how much is the impact, and then whether I can use a transfer function. Regression equation in other methods will also be referred to as transfer function. For example, when you're doing DOE, etc., you tend to, because it is not a regression anymore, you tend to call it transfer function instead of a regression equation. Okay, everyone? Next, correlation. Stats, basic stats, correlation. Again, same thing. Total product, total breakage versus, let's take a different one right now. To get your p-value, you will have to click the pairwise correlation table. Only then will you get the p-value. Click OK. Again, same thing. Start with p-value. Step 1. Look for p-value. P-value
0.082.
In the case of correlation, the null and alternate are very different. Here, instead of calling it factor and project Y, dependent and independent variable, correlation is not able to do that. So here you will say variables are independent. In alternate, we will say variables are dependent. This is one of the
Because
biggest.
it is a correlation.
Yes. It is not able to explain causality. It is not able to verify which factor impacts which factor. It is simply telling you that these two are related, these two are not related.
Yeah.
By virtue of getting our p-value at 0.03, I am concluding in our example, p-value is 0.03. Hence, we conclude
Dependent.
HA as true. So we are concluding that variables are
Dependent.
because the correlation test does not explain causality. We prefer the regression analysis over this. Okay, people?
Yes, sir.
Correlation is mostly used when you want to do relationship between X and X, not between X and Y. Yes, someone was asking something.
Sir, in last class, after checking the p-value, we checked the confidence level of the factors. Here we are not doing that. We are doing that R-square value.
Confidence level or confidence interval?
Confidence level, I think. Last class, 0 to 1
Interval will come
probability.
about. Interval, it will come about. Interval is something that will determine most of your hypothesis test outcomes. So
Sure.
interval we will study. I'll show you the levels going forward.
Okay.
step 2. You are also getting a correlation value here. You see this? Here also, here also. Check for the coefficient of correlation as well. This value hovers between -1 to +1 to 0.
So
Meaning-
negatively or positively correlated.
Correct.
Either way,
Value-
dependent or not. Yeah.
Correct. We call it R value. R value around -1 will mean negative correlation. While if your R square is around +1 will mean positive correlation. And value around 0, no correlation. Everyone, we're good so far?
How
Yes, sir.
can the R value be 0, sir? When P value, we said that it is dependent based on P value.
Thank you for asking this. Please realize when we are trying to explore relationship between two variables, we are actually looking at two dimensions. One that we refer to as truthfulness of the relationship. What I see in the sample, will it happen in the population or not? That's called truthfulness. The other is the magnitude of the relationship. How strong is the relationship? The strength of the relationship is coming from R square and R value, while the truthfulness is coming from P value. So, funny story, in New Jersey, on a particular Friday, 13 children were born and all of them were girl child. Okay. As the dean of the hospital, he wanted to proclaim to the world that if you want girl child, please have your spouses being admitted at my hospital. What happened in those 13 cases? Can you that it will happen always?
No,
No, sir.
Truthfulness.
it is nowhere related.
It may be, it may not be. Or 13 as a sample is a very small sample to be able to draw that conclusion.
Okay.
Fair, everyone? So one element we are saying, what happened in that sample, will it happen? I will use the p-value to be able to decipher that information. R square or R value will give you the relationship strength. 13 out of 13, your R square will be very high. The magnitude of the relationship will be very high, but it may not be truthful. Everyone with me?
Yes, sir.
Naveen, Siddhant,
Oh, that's why we are mentioning R square, because we are only focusing magnitude on R square. So
Yes.
difference between R and R square. Okay. Negative or magnitude.
everyone, we are good so far?
Yes, sir.
Yes, sir.
Manjunath, good morning. Vajresh, good morning. Kanchan, hello. Nanushri,
Yes, sir.
this is Analyze. Please participate. Next 30 minutes, you will go zombies. This is a complicated portion.
Sir, here, what is the industry standard for R
We
value.
use the same 62%, 0.62 or 0.67. Some industry leaders, some industry books will tell you 0.67, negative or positive is considered high relationship.
Okay. Basically, it's 2/3 as you mentioned.
Correct. Correct. All of you know how to make a scatter plot. Yes? But still let us do it. Graph, scatter plot, the third option with regression. Press OK. My project Y was total breakage. I am trying to find out whether production impacts. I want to find out whether machine A impacts. I want to find out whether total breakage is impacted by baking time, total breakage versus baking temperature. All kinds of scatter plots can be drawn. And every time this line moving upwards is showcasing there is positive correlation. But if you were to hover your mouse and feel lucky, you will also get the R-square value here. Am I getting it? I am fed up of this minute app.
Now,
No, sir.
How is that possible?
symbol row.
In some of the cases we get, in some of the cases we don't, sir.
You have a R-square value of 18% in the next case. That's possible that you will not give me. Hello,
Maybe
good morning.
on the line you have.
Very difficult. Very difficult for me. Yeah. How is this possible? The size possibly has impacted that. So 18% not good enough. This looks like 5% or 1%. 2.2%. Rubbish, nearly no relationship. Here, negative correlation. Let's look at the R-square value. 1%, 1.5%. So when you are drawing the scatter plot, remember two things. Always choose the third option with regression, because regression line is pictorially making things clearer for you. So I will always prefer the third wala line, and then look at the R-square value. If you're not getting it somehow, do the regression and get the R-square value. Everyone with me?
Yes, sir.
Yes, sir.
Yes.
Sir, in layman's term, I understand correlation, but what is the regression term mean? In simple terms, if you can put it.
You are essentially, because both of them are continuous data, you are trying to build a line equation for them. You are saying that if I were to do a prediction line, if I want to draw a straight line between both of them, you are trying to do that slope concept to be able to build that relationship between X and Y. So you are creating a XY indice to be able to get the answer.
Constant plus that function of X. Sure, sir.
Everyone, please spend 5 minutes. Do this quickly. Ask me any questions if you have, and then we will proceed further. Okay? Sorry. Done, everyone? Questions?
That, what is the difference between R square and R square adjacent?
We'll talk, don't worry. All that.
Sir, if the data type is continuous in both cases, then only we will use correlation and regression.
Yes.
Sir, before regression, can we go for correlation?
Why do it? Why do the same thing twice? I save the correlation when you are establishing relationship between two factors. Don't use correlation. And once we have a deeper dive into the subject, you will be in a better position to take that decision. Don't worry. People, questions?
I think no question, sir.
As of now, no questions, sir.
Good. Naveen Prasad, Siddhant, Dhanushri.
No questions.
Sir, last correlation will affected by the outliers, sir, or if it is the presence in the data.
Hold your horses. We'll talk about all this a little later. And when I will talk about some other values, we'll look at it. We'll look at it. Okay. Now we are getting into the second category, Y continuous, X discrete. If your Y is normal data, your Y could be non-normal data. If your Y is normal, then you are going in for a set of tests that are referred to as mean tests or parametric tests. If you are looking at non-normal data, you are going for median tests or non-parametric tests. Let's start with the mean tests or parametric tests. Before we start this, a very important logic that we have to study is referred to as confidence interval. Please realize that we are often looking at samples, but our subject of interest is population. Agree, disagree, people?
Yes, sir.
So let's say I have, like in this case, I have data of how much what is the quantity of broken biscuits. So I took out the mean of the total breakage, but actually that mean is sample mean. Correct, everyone? Because I have
Yes, sir.
sample data only. But
sir.
mathematics gives you the option of concluding where the population mean is expected to lie. You can estimate where the population parameter is expected to lie. That range is referred to as confidence interval. Everyone with me?
Okay.
If I do a simple graphical summary right now, I go to stats, I go to basic stats, I go to graphical summary. Let's say my project is total breakage. So if you see here, my mean is 11.43. Everyone, you can see this?
Okay.
This is my sample mean, but it also gives you a range where the population mean is going to lie. And this is giving you with 95% confidence. This is the range where the population parameter is expected to lie. That range is referred to as confidence interval. This is confidence interval of mean. You have a confidence interval of median. You have a confidence interval of standard deviation. So based on your sample, it can calculates your population behavior for your mean, median, standard deviation, etc. And in hypothesis, this is going to be a very important question. Yes, someone was asking something.
Yes, sir, my question. So the data which you are using right now, this is the sample data or this is the population data?
पॉपुलेशन डेटा कैसे होगा? ब्रिटानिया 150 साल की कंपनी है, तो 150
नहीं,
साल का प्रोडक्शन
अभी-
निकालोगे तुम?
अभी 150 साल का तो पॉसिबल नहीं है, बट द थिंग इज दैट कि इफ यू आर सिलेक्टिंग अ 6 months ऑफ डेटा, आई एम नॉट श्योर, मैं जस्ट मान रहा हूँ कि अगर आप हम प्रोजेक्ट रन करें ना, उस प्रोजेक्ट में हमें वी आर गेटिंग अ डेटा ऑफ लास्ट 6 months, बेस्ड ऑन दैट वी हैव टू डू द प्रोजेक्ट. So now at that moment it would be my sample data or it would be my population data?
It is sample data. You only taken 6 months of data. 6 months cannot be considered as population.
So,
This-
sir, that means we
No,
take the
sir, I
sample
have the
data.
same.
Yes. November 6.
Okay. Sir, I have the same question as Kanchan. So we are using a sample data. Then how the Minitab is coming up with the numbers?
Calculation
addressing
is
the
very
population?
simple. Calculation is
Yeah.
very simple. I will talk to you about that.
Yeah.
Calculation is very simple.
That
There
is
is
basically our question, because we are
Okay.
Margin of
addressing
this-
the population, but we are not having that data.
So, sir, the normal thing is that whenever we are running any kind of project based on the data of 6 months or 1 year.
Don't jump the gun. I have not spoken anything. I've just told you what is the meaning of confidence interval. I am not going to answer any question after. How do you use it? We'll discuss in the subsequent tests. Don't worry.
No, I'm
Just-
not asking you the test or something. I'm just asking for my understanding. So whenever we are doing any kind of project, at that moment we are collating data. So that collating data of 6 months or 1 year always should be considered as a sample data.
Absolutely.
So
Population का
everywhere
मतलब तो पूरा डेटा चाहिए मुझे. AIG is a 15-year-old company. You want to understand sales का performance. You've taken data for last 6 months, sample data. It's taken 1 year data, sample data. I'm not willing to call it population data unless the world changed. So let's say AIG has transformed itself for the good or for the bad. You are saying it is a new company now. Then I'm willing to call it population data. Otherwise, it will be referred to as sample data itself.
sample data.
So if we take the full old data of our company, then it will be population. Or else it will be sample.
But basically, no one does does that. So basically, whenever we are doing the project, it is sample data only.
सोच के देखो ना.
Yeah, whatever the data
I
we are taking, that's sample.
Sample data
Stronger,
itself.
I want to understand what is your health. Should I extract all your blood or should I only take sample?
Extra all of it, sir. Shunga is asking so many
India is a
questions.
country with about India is a country with about 120 crore population. If you as a television company want to understand what is India's voting tendency going to be, do you have the courage, the money, the time to be able to talk to 140 crore people? Most
No.
of the time, sample is taken because the population is too costly. Sometimes
Yeah.
it is not doable.
Yeah.
So we are
So,
saying,
sir, I have one doubt that how
Please,
can we
please.
conclude that this much of sample, whatever we're taking, is sufficient to conclude that
there are statistical tests that will tell you how much data do you need for how much confidence level.
okay. That we'll study in the further.
So we are saying in the Y continuous X discrete category, we are looking at three basic tests. One test which is referred to as one sample T, another that is referred to as two sample T, another that is referred to as one-way ANOVA. Is this all? No, this is not. This is a very, very large set of tests that you can do. I'm only talking to you about some tests. One sample T is ideally used when you want to compare mean of a group to standard. Two sample T is used when you want to compare mean of two groups to each other. If you are looking at comparing mean of greater than two groups, then you are looking at one-way ANOVA. Let's understand this. One of the basic prerequisites that we discussed was that data has to be normal. Correct, no? We were saying one of the basic logic is Y is
Yes, sir.
normal data.
Mm-hmm.
So three tests. What is the test? What is the metric? Null alternate? When to do? Remark. Okay. 3. 1, 2, 3, 4. Okay. First test that we are looking at is a one sample T test. All these tests, what is the metric that they are using? All of them are using mean. So why are we doing this test? When to use this? When we are looking at comparing mean to a standard, or when you want to draw the confidence interval of mean. Let's understand these two terms that I'm talking about. One I'm saying is if I have a target in mind, let's go back to our data. So I have total breakage ka data. If I wanted to compare total breakage versus a target given to me by my company, by my customer, then I can use the one sample T test. Everyone with me?
Okay, understood.
Option number 2, if you wanted to find out what is the confidence interval of mean for total breakage, you could use the one sample T test. Let's do that. Stats, basic stats, one sample T test. Total breakage. Let's say as business, the company has given me a target that Pranay, it should not exceed 4. Okay, 4 kilogram. Press OK. Look at this very carefully. What is the confidence interval that you are getting? 11.07 to 11.78. Yes, everyone? This is what we are getting.
Yes, sir.
Yes, sir.
What is the
Yes.
question you asked? You asked a question to say that, is the mean equal to 4? What is the mean? Where is the mean lying right now? It is between 11.7, 11.07 to 11.7. Yes?
Yes, yes,
Yes.
yes.
That is why it will conclude that it is alternate hypothesis. It is obviously not equal to 4. It is much more than 4. Yes, people?
Yes, sir.
I'm saying one sample t-test. 2 usages. When to use? When you want to compare mean of a group to a standard. Or if you want to, for lack of a better word, draw the confidence interval of mean. Why is that important? Forget about the test right now. I'm not giving it a target. Forget about the target. It only gave me confidence interval. Can you guys see this?
Okay.
It gave me a confidence interval that it is 11.07 to 11.782. So how is this useful? A, for target setting. So Naveen, if I am your factory manager right now, I walk up to you to say that I want to do a as is, where is plant. So this is a current working plant. I want to do a copy paste. I want to do a new plant, but the same machinery, same kind of people. What should be the target of breakage? What are we currently doing? We are currently doing 11 to 11.7. Everyone with me? So if nothing changes, this is what your capability is right now. Everyone? If nothing is done significantly different, this will help you with as is mean. That could be used as a target. Everyone with me?
Yes, sir.
Number 2, if I'm doing a Six Sigma project, I'm doing an improvement project. I don't want to call it a Six Sigma project. I'm doing an improvement project. This is your current performance. Kanchan, this is what you're doing right now. So you can't give me a target anything between 11.07 to 11.78. This is what we are doing currently. For
Yes.
any improvement project, the goal must be outside
Of this country, CI,
confidence.
confidence interval, of course.
Leader will say it should be significantly away. You are currently doing 11.07 to 11.78. Shrungar says I'm doing a project to reduce it to 10. The leader will say nothing doing, reduce it further. But from a statistician standpoint, this is what you're doing. Anything less than this is significant improvement. Statistically speaking, what is the meaning of significant? Anything outside confidence interval is considered significant. Naveen Prasad, we are good. Dhanushri, we are good.
Yes, sir.
Yes, sir.
Sir, sorry, maybe I'm asking you too fast. I don't know. Sir, for
Hmm.
PPM also for the same way we can do the same, or we will use a different tool, sir.
You can do that. You can do that, but the test will change. The test will become one sample Poisson rate.
Okay, okay. Yeah, because
We'll do
normally
that.
in our
Don't worry.
plant we are in percentage or PPM. Almost in our plant, almost we are using discrete data only, sir.
No, so no problem. So the discrete wala test will apply. We'll use that.
Thank you.
Another thing we were saying was to compare mean to a standard. How do we use it to evaluate performances? Or when you want to validate the goal achievement in improve and control phase, this is mandatory. You cannot complete your improve phase of Six Sigma without statistical validation. Yes, no, black, white people. If you're doing a Six Sigma project on, this was your Six Sigma project, and you gave me a target that I will reduce it to 11. Unless you show me statistical validation, I will not agree to your improvement done statement. Clear, everyone?
Yes, sir.
Yes.
I understand the concept, but I have one basic question.
Please.
In this example, what is the factor we are considering?
We are not considering any factor. We are only talking about project Y right now.
Because why right now?
Correct.
Okay.
Correct. So first test that we looked at is the one sample t-test. And like I was talking to you earlier, technically what is happening in the background? Technically, it calculates the confidence interval of mean, population mean. If the target falls between CI, then it will call it null hypothesis, else it will call it alternate hypothesis. Let's do that.
Sir, just one thing.
Please.
So in the goal statement, we have to we have to derive what would be my goal statement and what would be my baseline. So in that scenario, to identify the project or to find out the baseline, I have to perform one sample t-test or the CI confidence interval to baselining.
Correct. If your project is mean, if your project is median, then there will be a different test. If your project is count, it will become a different test.
Yeah, so I'm just thinking that my with the help of normality test, my data is normal. Then we have to use this CI for baselining. Am I correct?
Correct.
So then this methodology we can also use in the define phase.
You have to also use it. It is mandatory.
It will be my predefined phase.
Yes,
If you don't give me that in your goal statement, in the goal statement, if I am your master black belt, I will mandate that when you write your goal statement, give me the CI. I want to see the CI before I approve your goal statement.
Okay.
Basically, guys, if you want to know the as-is conditions, these are all the statistical analysis.
Correct. Correct. Here, like you saw, p-value was 0, meaning alternate was true. Null in the case of one sample t-test is saying mean is equal to 4. Alternate is saying mean is not equal to 4. Based on the p-value, you found out that p-value is not equal to 4. Obviously, the confidence interval is 11. So if I added a value, a target like 11.5, tell me a value that I can get null hypothesis here, people.
11.
11?
11.5 or something.
Let's say 11.2. Now, because question was, is the population mean equal to 11.2? It looked at the confidence interval. Because 11.2 fits between this, it is saying null hypothesis. Everyone with me?
Yes, sir.
Yes.
Shungar, Naveen, Manjunath,
Yes, sir.
Vajresh. Pakka na? You good so far, everyone?
Yes.
Yes.
I have the same
Let's take
question,
a
sir.
10 step. What?
That factors we are looking for the factors now, but
No,
we
no,
are
we are
still
only,
on the why.
so we are saying why, what are the usages? You're saying, I want to compare a continuous data mean against a standard. Okay.
Mhm.
I can either do breakage for the entire plant, or if I have shift-wise data of breakage, I can do that. If I have
Okay.
machine-wise breakage data, I can compare. So you can inbuild your factor based on your data collection itself.
Mhm.
Got the thought?
Okay.
Naveen, please, can you keep writing on the chat the questions that you guys have asked? You asked R square adjusted, R square predicted, so that we have that in the parking lot and we answer those before we finish. Okay? Just put that in the chat so that we don't forget. 10 minutes ka break. We meet 9:20. Okay?
Yes, sir.
Everyone, are we back? Next test that we are looking at is the two sample t test.
Two sample T.
Yes. Here we are necessarily looking at comparing mean of two groups. Compare mean of two groups. If I pull up some data, let us assume for a minute that my project Y is continuous and normal. I'm doing a project on color. किसने कर दिया यार? This is my project Y collections. This is continuous data. Everyone, Y continuous.
Collection. What is it, sir?
Yeah, this is the amount of money that you've been able to get from your customers that have been due with you.
Sir, that will be discrete, right?
No, this is in dollars or rupees.
Currency.
This will be
okay,
continuous
okay.
data. So I have team leader, which is X discrete. Everyone, I am checking how many subgroup does it have. If it were only two subgroups, I would have done two sample t test. If it is greater than two subgroup, comparing more than two means the test that we use is one way ANOVA.
Oh, one way ANOVA.
Everyone with me? I have a factor here.
You can do two sample T test for fail and pass.
Yes,
There is
fail
some-
pass I can
or
do.
male-
I can
male, female,
do
yeah.
here. Yes, I can do the 2T test here. I have previous experience. Again, I'm checking three subgroups. Three subgroup means one way ANOVA. Everyone with me?
Yes, sir.
Yes, sir.
Tenor,
Yes.
again greater than two subgroups. One way ANOVA. Gender, two subgroups. Two sample.
Or maybe others. We cannot say.
Shift, how many subgroups? More than two. One way ANOVA. Still missing a A here. Marital status, two subgroups, 2T test. Everyone with me?
Yes, sir.
Education, more than two subgroups, one way ANOVA. Similarly, let's pick up this is data for cycle time. My project Y is cycle time. Again, I am assuming that my project Y, which is cycle time, is continuous data and normal data. So I'm saying Y is continuous and normal. Only then can we do the mean wala test. I'm now adding the filter. Shift. How many subgroups do you see? Greater than 2. Yes, everyone?
Yes, sir.
Yes.
Matlab, one way ANOVA. Machine number much more than 2. Again, one way ANOVA. Total shift breakdown. Continuous data, discrete data. People?
Minutes, it's in minutes, so it can be continuous.
X continuous. This is also X continuous. This is also X continuous. What test do you do? Y continuous, X continuous?
Regression, correlation,
Regression
and one more.
or correlation.
What is
And the graph that you build.
scatter plot?
Right. Production manager or something greater than 2, again one way ANOVA. Do you understand, everyone? If your Y
Yes,
is
sir.
continuous data and your X is discrete, then you have the option of choosing the 2T test or one way ANOVA test. 2T only when the X has 2 levels. If you have more than 2 levels, you are doing the one way ANOVA test.
So one sample t test is basically on Y itself. It does not
Right.
consider the X factor.
Yeah.
Okay.
Null in the case of two sample t test will say mean of both groups is equal. Alternate will say mean of groups are different. In the one way ANOVA, null will say mean of all groups are
Is equal.
equal. Alternate will say at least one. Mean of at least one group is different. Let's do this. Stats, basic stats, two sample t test. Y is total breakage versus X, which is in pass fail. P value is 0. It is saying that the mean are not equal. If you want to see it graphically, I will draw interval plot. With ANOVA, you draw interval plot. With group, Y total breakage versus result. When I have deployed 10th pass machine operators, my breakage is much lower than when these people are not 10th pass. Everyone with me?
Yes, sir.
Let's change this to something else. Yes, no, I have. If the confidence interval is overlapping, it means that this will be null hypothesis. If the confidence interval are different, you see that there is no overlap between them, then it will be alternate hypothesis. Stats, ANOVA, one way, Y is total breakage versus X, let's say O1. Let's look at the graph. This is a confidence interval it is giving you. I see that there is fair bit of overlap between all of them. Yes, everyone?
Yes, sir.
Yes, sir.
Then it will become, p-value will become null hypothesis. Kanchan, we are good. People, we are good so far.
Sorry, sir. I'm in a call in between, so that's why I a little bit.
Okay.
I need
Again,
some time, sir.
Okay.
I'm on, so I'm just I'm here, but a call is also very important.
Okay,
I
sure.
will let you know about that.
So physically here.
Yes, it's needed.
Collection versus previous experience. Press OK. Let's look at the graph first. This confidence interval is not overlapping this one. Correct, everyone? इसका मतलब it will become alternate hypothesis. P-value.
Yes.
The same logic applies for your R square also, like we did in regression analysis.
So, but here we are comparing between two variables or three, more than two variables.
Not variables.
But we are not.
Variable is one.
But factors. Sorry.
Variable is one. That variable has multiple levels.
Levels. Yeah. But we are not focusing the impact of X and Y, right?
No, this is X on Y. So you are now saying you wanted to find out whether employee previous experience is impacting collections or not. You saw that if I have someone from calling background, customer service background, and outbound sales background, people who are from outbound sales background have the lowest collection.
Okay. We are doing this with respect to Y itself. Okay, understood.
Now let's look at a different example. I am trying to find out. I will have to stack the data. Give me 1 minute. If you see, machine-wise data is given here. This new Minitab does not allow unstacked information. So we will have to first stack the data. I go to data.
Separate a column and.
So I will have to put all of them together.
I
selected this. Pressed OK. So this is my machine. This is my breakage.
Oh, this can be done easily through Minitab.
Yeah. One way.
I used to do it manually in Excel.
Yeah, in MSA also we can do this. For
Say that
MSA, for MSA also we did it in Excel. We can still do it in a Minitab.
But
Look at
Shunga
this.
spent so many times doing that manually in our previous examples.
Yes.
Look at this machine level defect data. You see that machine F is creating a lot of defects, while this machine number D is the best performer. Everyone?
Yes, sir.
Please practice this. 1T, 2T, 1V ANOVA. Ask me any questions if you have.
Sir, can you do one more time that stacked one?
Sure.
Different column in one column.
Sure. I'll do both. Let's start with unstacking, and then we stack it. Look at the data first. I have maybe collections data. Give me a second. If you see, I have collection data in one column and team leader data in another column. If you want, Naveen, to have collection by team leader, I will unstack it. I go to data, I go to unstack. Unstack what? Unstack collection. Basis what? Basis the team leader. Now look at what it will do for you. It has created separate columns for your team leaders. Fair? Now let us
Yes, sir.
do the opposite. Let's stack it. Data, stack, columns. Which columns do you have to stack? All of this.
All of it.
Where do you want to put it? In a new worksheet or column in the current worksheet? I will say C7, C8 is empty right now. So I will say C7, C8. Now this will become compiled information. This is now my collection. This is my team leader. Everyone with me?
Yes.
Yes, sir.
Please practice. Ask me anything if you're stuck somewhere.
So can you please share those data with us so that we can practice?
That again? Sorry.
Can you please share those data with us
Sure.
so that we can practice?
Should I put it on your WhatsApp? Or
Yes,
should I?
yes. Both are okay. Both are okay. WhatsApp or chat.
Sure. Half a minute. तुम हमें जानो, तुम्हें जानो, मगर लगता है कुछ ऐसा मेरा हमदम. Sent. Whatever we've done today, are we good with that? Do you have some questions? Because tomorrow we have a very small portion to do, which is the median wallet test, and then we'll move forward from there.
Okay, sir.
So please send the notes in the groups.
I'll send you the notes, and I'll as soon as the video is also ready, I will send you that as well.
Yes.
So that the video will become very useful in this case. Video will become very useful in this case. Cool then, people. I'll
Sir,
see
I
you
think
guys.
R square adjacent and prediction, that I think
Tomorrow, because I want to technically explain that to you guys. Please understand, when you are, let me show you this. So when you are doing a one-way ANOVA test, especially, if you see, you see these values here, the analysis of variance values here. So here you are necessarily saying, out of the total variability of 289, 601, 1184, out of the total variability, how much is contributed by the factor? This becomes your R square value. Tomorrow we'll mathematically do it. We'll do it with calculator and all that, so that we understand this well. Don't worry. Okay, I'll see you guys tomorrow, 8 o'clock. And please, everyone, please try and be on time tomorrow, 8 o'clock. so that we
Sure,
don't
sir.
lose 10-15 minutes. Okay, everyone, see you tomorrow
Sir,
then.
Just one confirmation, sir.
sir,
Is there a class on day after tomorrow?
No, no class on Thursday. I'm traveling
Sure, okay. So tomorrow.
tomorrow. Yes.
sir, I have one concern. Sir.
Hmm.
I have taken an example of the manual
Hmm.
emissions.
You sharing something, Manjunath?
Yes,
Yeah.
yes. Shades.
Hmm. Hmm.
Sir, I have taken return quantity versus complaint category.
Ideally, return quantity is count data. Ideally, you should not be doing one way and over here,
Discrete
but we can do
assessments.
it for practice sake. Yes. So
Yes,
you
sir.
didn't
For practice
with complaint
purpose, I-
category. Okay.
Mhm.
P value is 300.306. And your R
Yes,
square
sir.
also is very poor. R
Yes,
square,
sir.
not yet adjusted. Look at the next left one,
Left of
R square. Yes, not S. This one. R square is 1.8 or something.
1.65.
0.65.
6. So even the magnitude is poor and the p value is also very poor. So all your
Yes, sir.
issues.
Can we take that consideration with respect to the defect category wise? Can we do analysis in one ANOVA using?
Did not understand. Say that again.
Yeah, we can correlate that complaint category wise, which defect type is correlating much more to the quantity. That perspective we can use for this ANOVA to.
Correct. Let's use this example also tomorrow. Have you
Yeah.
checked complaint category is normal or non-normal? Return quantity is normal or non-normal?
No, sir. Only I went
Go to
through
stats.
one more now.
Okay, go to stats. Basic stats. Third option. Graphical summary. Return quantity.
Choose return
Acha.
quantity.
Okay. Remove that. Okay. Your p value is the data is not normal. It is not normal. Good.
So
Is
median
normal.
wala
So
use kar.
it is,
We have to do median wala test. Sara.
yes.
think they have to use man Whitney, sir.
If your category is 2, then you will do man Whitney. If you have more than 2, then you will do moods median. I'll see you guys tomorrow then, everyone.
Yes.
Bye.
Yes.
Bye.